All right, everybody ready? We have an exam on Tuesday, right? We have our exam on Tuesday, right? So let's try and get through the 8.6 material today so that I can start looking at the review with you and answer questions. So first thing I want to point out, anyone that wasn't here last time that needs a copy of the formulas? You want a copy? Yeah? Got your truck okay now? Truck, yeah. Car? Okay, okay. Anyone else want a copy of this formula sheet? No? Okay, so on the formula sheet, I have it over here on the screen. What I've highlighted in yellow is everything that we have done up to this point. So everything on the left-hand side, everything on the very top, right? That was the definition of sine and cosine. Why does this? Okay, there it is, sorry. Let me zoom that in a little bit. So we've done everything on the top. That was, weeks ago. And then on the left side, the fundamental identities we talked about. Within the fundamental identities, those three equations right there, I know it's hard to see that. Those are your Pythagorean identities, right? The very important ones. The most important being sine squared theta plus cosine squared theta equals 1. Then we have the even and odd properties. The last class or two, we've done the sum and difference formulas. And today what we're doing is the top right here, this blue box. We're going to do the double angle formulas and the half angle formulas. All right, that's what we're going to do today. And then later on, we will do the rest of these, all right? And then we'll do the stuff on the bottom of the formula sheet. So I just want to kind of give you an idea of what it is we know off this formula sheet already and what it is we haven't established. Yes?
Does that mean 8.7 won't be on the exam?
That's right. The exam will end with the material from today. Yep. Okay, so rather than sit here and write all this stuff out and waste time, I wanted to see if I could walk you through where the double angle formulas come from. And then after I'm done with this, I'll show you where the half angle formulas come from. So those formulas that are on your sheet, look at the ones that say double angle. I'm gonna prove to you where all of those come from right now, all right? So the first one is that formula. Y'all see that formula there? Sine of 2 theta, you see it on your sheet? Yes. Do you need one? Yeah? Anyone else? Okay, so y'all see that there? Sine of 2 theta equals 2 times sine theta cosine theta. Where does that come from? Well, what we do is we go back to the class before 2 classes ago, when I showed you the sum formula, right? Sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. And what we do is we use that formula, but we replace alpha and beta with the same angle. So we just, instead of using alpha twice or beta twice, the book uses theta. So if I just replace alpha with theta and beta with theta, then we get sine theta cosine theta plus cosine theta sine theta, right? These are exactly the same expressions. They're just written reversed. And multiplication doesn't matter how you do it, right? So I can reverse this one and make it sine theta times cosine theta. And then I have 2 of them. Put them together, I got 2 of them, and I'm done. So do y'all see it's not really a magical thing here that's happening? It's just using this formula with the same angle in there. All right? We call that the double angle formula for sine. Why do you think we call it the double angle?
2 angles?
Yeah, 2 times theta. We're doubling some angle, right? And that's the formula for it. So what this formula allows us to do is take sine of twice some angle and figure out what it is by just knowing what sine of the angle is, not double the angle, but just the angle itself. So in calculus, you use this formula whenever you have 2 theta, but you would really like to have just theta. You use this to kind of convert it to something with just theta in it. All right, you with me? All right, now, for the cosine 2 theta, do you see that there are 3 formulas for cosine 2 theta on the formula sheet? Y'all see them? You can look at yours. Right, there's 3 formulas. So I'm going to show you where they all come from, all right? First, let's figure out what cosine of 2 theta is. The first formula up there is cosine squared theta minus sine squared theta, right? Let's see where that comes from. Well, we go back again to this formula from last class. Cosine of alpha plus beta is cosine alpha cosine beta minus, remember with the cosine it was the opposite, and then sine alpha sine beta. We take that formula, replace alpha and beta with theta, and then when we write out we get cosine theta minus sine theta times sine theta. These two multiply together to be cosine squared theta. These two multiply together to be sine squared theta, but we have subtraction. If that had been a plus, then this would be 1, right? But it's a minus, and so we just have to leave it just like that. Okay, that's the first formula. Questions on that? All right, we call it the double angle formula for cosine again because it's double the angle. Then, well, how do I explain this? So here we have, again, double the angle, and then we have a new formula that doesn't have double the angle anymore, right? It doesn't have double the angle. However, this one has cosine, this one has sine. Sometimes, again, later on, we might like to have cosine of 2 theta rewritten where we just have cosines here, or just sines, not mixtures of cosine and sine. So what we can do is we can just rewrite this formula right here, but replace the sine squared theta with this. That's from the Pythagorean identity, right? Do I need to explain that? Sine squared theta plus cosine squared theta equals 1. You move the cosine squared to the other side, and you solve for sine squared, and you get this. Do I need to explain that or not? And now all you do is distribute a negative 1 through. What did I do there? Oops. I made a mistake. Y'all see my mistake? Yeah, this is minus, sorry. Minus and minus, right? So let's double check it. Is that what's on their formula sheet? It's a minus, right? So when I distribute this through, I get minus 1, and then I get plus cosine squared theta. Now I have 2 cosine squared thetas. I add them together, get 2 of them, and then have the minus 1. See it? No questions? So again, the advantage of this is that to figure out what cosine of 2 theta is, all I need to know is what cosine of theta is. If I know that, then I can figure out what cosine 2 theta is. Here, same formula we start with over there. Start with that. Replace the cosine squared with 1 minus sine squared. Again, Pythagorean identity. And then you can just drop the parentheses, put this sine squared and that sine squared together. You get 1, take away 2 of those sine squareds. And that's the third formula for cosine 2 theta. So for cosine 2 theta, we have 1, 2, 3 formulas, right? For sine 2 theta, there is only one formula. That's it. We don't have 3 different versions of it. Okay? Now, tangent 2 theta, right? Tangent 2 theta, I didn't put it up here on the board, but we can do it in so many different ways. All you'd have to do, I'm going to erase this. Where do I want to put this? Let's put it, I'll do it here. So remember, tangent of 2 theta, right? That should be sine 2 theta over cosine 2 theta, right? That's the definition of tangent. And then I can rewrite sine 2 theta using that formula, right? So the numerator would become 2 sine theta cosine theta. And then on the bottom, what do I put? Cosine 2 theta, right? Which one do I put? I mean, I have 3 to choose from, right? So which one do we want to put? It's really up to us. Okay, we can put anything we want. In order to get their result over there, let me see. They get 1 minus tangent, so I'm going to take this one right here. I'm going to use this one. So cosine squared theta minus sine, oh, forgot the minus. Minus sine squared theta. Do y'all agree, just right off from what we've just showed, that that's what tangent 2 theta is? Yeah, and that's not the formula, right, according to your sheet? So in order to get the formula, what you do, does anyone see it or not? Wondering if anyone sees what I do to do this, to make it turn into that formula. It's not super obvious. If I want to turn this into, what does it say there? 2 tan theta over 1 minus tangent squared theta? Yeah, you would have to turn that into a 1, right? To match the formula to the bottom left-hand corner. And this would have to become a tangent squared, which means you have to divide both of these by cosine squared, right? But if you do that on the bottom, you have to do it on the top as well. So to get that formula, all we're doing is this. Oh, I made it. I'm surprised as well. All right, so what I'm going to do is I'm going to multiply by 1 over cosine squared theta on the top and bottom. Look, I'm not expecting that you would do this. Like I'm not going to give you a test problem where I say, go show that this formula is this formula. I'm just trying to show you where they come from so that we can start using them. All right, so to do this, let's do the top first. When I multiply this times this is multiplication between everything, right? So there's no like distribution. It's just going to turn out on top to be 2 sine theta cosine theta. And then this multiplies, so it's just divide that by cosine squared theta. Now on the bottom, because there's 2 terms here, right, separated by subtraction, this would have to distribute through. And so it would become cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. And then one more step and we're at the answer, right? Do you all see it? One of these cosines cancels, right? This becomes a 1, and that's tangent, right? That's tangent. And this sine theta that's on top of that cosine theta turns into what? Tangent. So we get on top 2 tan theta, and on the bottom we get 1 minus tangent squared theta. Okay? All right, so we have new formulas, these double angle formulas, right? Now I'm going to show you where the half angle formulas come from, all right? Show you where these come from. So let me see here. Where do I want to go with this? Is it worth it me showing you this, or do you want me to just give you the formulas and let's just do? Y'all? You want to see where they come from? Okay. All right. So for the half angle, I want to write something down first. Okay. I want to see. It's raining. I was saying I heard it's gonna be 85 degrees today, and sunny. It's drizzling. Drizzling. That's not rain out there. Okay. So tell me if you agree with this or not. Let me do, you know what, I think I'll do just maybe one of them, not all of them. It might take me too long to do it. Let's take this one right here. Let's take cosine 2 theta. Now there's 3 different things that can be, right? There's 3 different things that can be. What I'm going to do is I'm going to write the second one, 2 cosine squared theta minus 1. Okay, we all agree that that's true? Yeah? What I want to do here is I want to just make sure you understand that this angle here, whatever it is, this is twice that angle, correct? Whatever that angle is, this is twice the angle. So could I write this? Could I write over here 2 cosine squared, but instead of putting theta in here, could I put theta over 2 minus 1? So I'm replacing that theta with theta over 2. And that means, according to this formula, this side should be cosine of what? Remember, I just said that whatever angle's here, this is twice that angle, right? So if I put theta over 2 here, what would go here? Then they would be the same angle. This is theta, this is twice theta, right? That's the master formula I'm working with here. What I'm doing is I'm saying, please replace theta with theta over 2. Then according to this formula, what would this have to be? Theta. Just theta. You're multiplying by 2. So you're multiplying that by 2, right? Doubling it. So this would just be theta. So are y'all okay with me writing that? And that's just me writing this formula in kind of a different way. Yes? Okay, next thing I'm going to do, I'm going to try and get cosine theta over 2 by itself on one side of the equation. So I'm first going to add 1 to both sides of this. So if I do that, I get cosine theta plus 1 equals 2 times cosine squared theta over 2. Y'all agree with that? Just add 1 to both sides? What do you think I'm going to do next to get this by itself? Divide by 2. Okay, so I'm going to take the left-hand side, divide by 2. Pressure's on now. Oh, shit. Oh, geez.
So close.
Not really. Thanks for making me feel better, though. All right, so I'm going to take the left side, divide by 2. Cosine theta plus 1. I divide it by 2. The right-hand side is now cosine squared of theta over 2, right? Just divided both sides by 2. And I'm trying to get cosine of theta over 2 by itself, so I need to get rid of the squared. So what do? Square root, both sides. And whenever you take the square root on both sides of an equation, you must do plus or minus, right? So I'm going to take plus or minus the square root of cosine of, I'm just going to put theta plus 1. I'm not putting the theta in parentheses there, over 2, equals cosine of theta over 2. And that is your half angle formula for cosine. That's your half angle formula for cosine, which is on your sheet, right? You see it, the half angle, it's to the left of the double angles. See where it says cosine theta over 2 equals plus or minus 1? Oh, you know what, they have it backwards. Okay, they have that reversed order. All right, big deal, right? Okay. Now, to do the other one, to show, do you see that above that one is sine theta over 2 and it has a formula? To do that one, what you would do is you would take the formula cosine 2 theta. You would start, you know how I started here with this one? And I had 2 to choose from? If I chose the other one, 1 minus 2 sine squared theta. If I started with this one, replace that with theta over 2 and that with theta, and then solve the same way, I would get the other formula, which I'm not going to go through. All right? All right. Those are the formulas. And tangent, I'm not going to go with tangent theta over 2. I'm not going to show it to you. You just take that one on faith. All right? For time's sake, I'm not going to prove every single one of these. All right, so now that we have them, right, we need to use them. Are y'all going to have all those formulas memorized by Tuesday?
Memorize?
Oh, no? Hell no. Hell no. Oh, your game's coming out? Oh. So there's a pretty big debate in our math department about this. Like, do we allow students to have these or not? Some faculty are really adamant about no formula sheets. You know, students need to know this. I'm of the opinion that, you know, you're never in the real world ever going to be locked in a room with no access to any information unless someone's trying to torture you, right? So you're allowed to have them for me, right? But just be aware that when you get to the calculus classes, you know, you might find a professor who's not as open to that idea and wants you to memorize things and stuff. So just be aware. When I was in calculus, my Cal 1, I didn't have to memorize things, and Cal 2, I did. So it sucked because I hate memorizing things. But it's the way it goes. All right, here we go. So first things first, let's do this problem. If sine of theta equals 1/4, and I tell you that theta is between 0 and pi over 2, I want you to find the following. Find part A, I want you to find sine of 2 theta. B, I want you to find cosine of 2 theta. C, I want you to find sine of theta over 2. And D, let's find cosine of theta over 2. So what I'm giving you is information about sine of some angle theta, right? I'm giving you some information about that. And I'm giving you a restriction for the quadrant. From this, and you know, this is kind of like what we've done this whole class, we should be able to recover everything about theta from this, right? We should be able, from this information, we'll know sine theta, cosine theta, tangent theta, secant theta, cotangent theta, everything we ever need to know about theta, right? And then to answer these questions, we will just use the formulas, right? That's all we're going to use. So first things first, let's do what we've been doing. Draw a picture, figure out what quadrant this angle's in, figure out x, y, and r, right? Find all that information. So I am in quadrant 0 to pi over 2, right? So I'm in the first quadrant, right?
Yeah.
I'm some angle over here. It has some x and y coordinate and some radius r, or some r, right? And since sine is 1/4, right? That tells me that my sine is y over r, thank you, y over r, right? So that tells me my y coordinate is 1, right? Which makes sense because I'm in the first quadrant, the y coordinate should be 1, or positive I should say. The x coordinate I don't know, but I do know the radius is 4. And then I use Pythagorean, and by the way, if you know, the formula sheet has all this on there, right? If you zoom in here to the very top of this sheet, there's the picture right there of what we're doing, right? Now they call it A and B, but we've been using X and Y, right? It's the same thing. You have the little Pythagorean right there, but they've even solved it for R for you. So what I've been doing in class, I've been writing, okay, we now use x squared plus y squared is r squared, right? That's our Pythagorean. And we know y is 1, x we don't know. So we get x squared is, so if x squared is 15, right? 16, take away the 1, bring it to the other side. So x is plus or minus root 15. X is plus or minus root 15. And it'll be positive because we are in the first quadrant, right? So we are, this right here turns out to be root 15. Got it? So what we've done, right, is we now know this. We now know that sine of theta is 1/4. We know that cosine theta is root 15 over 4. We know that tangent theta is 1/4, is 1 over root 15, right? And I could keep going, right? I can tell you what secant, cosecant, cotangent. The only things I need, well, you tell me, what are the only things I need to answer the questions, to answer these questions? I only need sine and cosine. That's it, right? Like when you think about these formulas that we're going to be using, right? They all involve sine and cosine, except tan 2 theta, right? Except tan 2 theta. For that one, you need to know what tangent is. So if you just know what sine, cosine, and tangent are, you can do every half angle, every double angle that you would ever need just off of those 3 pieces of information. Got it? Okay, let's answer part A now. What happens if you screw this up? These are all wrong, right? So take your time, make sure you know what's going on here. Part A. If I want to know what sine of 2 theta is, I'm going to use the formula. That's 2 sine theta cosine theta. But that's just 2 times, well, sine theta for me is 1/4, right? And cosine theta for me is root 15 over 4. And so my answer here is, let's see, I can reduce this, right? I can get rid of that, make that a 2. So root 15 over 8. Y'all agree? Root 15 over 8? What's wrong? Is that sine theta, 1/4? Is that cosine theta? What's wrong? Y'all are everyone's giving this look like, what the hell did you just do?
Because you did that first part.
Oh, you didn't like this, did you?
Yeah.
Okay, well, if you didn't like that, then you would have got 2 root 15 over 16. So you just go, remember, 2 is 2 over 1, right? Just go straight across. That's what you would get, right? Then you reduce that. 1/8. That better?
Yeah. So much better.
Okay. Anybody else? Part B, cosine 2 theta. All right, so as soon as I see cosine 2 theta, I start thinking, well, wait a minute, hold on. That has 3 different formulas, right? Which one do we use? Well, we can use any one we want, right? But which one makes the most sense to you? Should we use the one that is 2 cosine theta minus 1, cosine squared theta minus 1, 1 minus 2 sine squared theta, or the original one, cosine squared theta minus sine squared theta?
The original?
The original, okay. Anyone have any objections to the original?
I would probably do 1 minus 2 sine squared theta.
Why? So you want to do 1 minus 2 sine squared theta because then you don't have to deal with the radical?
Yeah.
And then, what were you going to say?
Because we just got the sine 2 theta.
Yeah? No? You know which formulas I'm talking about over here, y'all? Right? I get to choose one of those in red there. I get to choose one of those, right? I like the idea of, hey, let's use the sine as 1/4 because it doesn't have a radical in it, right? I agree with that, but even better, let's use the sine theta not because it's not a radical, but because that was given to us in the problem. So if we screwed up cosine, right? What if we screwed up cosine? Then we're going to screw up this answer, aren't we? But if we use the formula that requires sine theta, and they already gave that to me, then I'm not going to screw that up. You know what I mean? It's just safer. You can use any one, but I'm going to use the one that seems safer. So I'm going to go with the 1 minus 2 sine squared theta. All right, I'm going to use that formula right there. Now be careful here. 1 minus 2, order of operations here. Sine squared theta means you take sine theta, I'm writing this very slowly for you, and square it, right? That's what this notation means. This is 1 minus 2 times, okay, what's sine theta? 1/4. So I'm going to do 1/4 in here and square it. Now, order of operations, like I just said, you have to square that before you do anything else, right? So you're going to have 1 minus 2 times 1/4 is 1/16. Right? This is not -1, right? You have to do this multiplication first. So 2 times 1/16 is 2/16. That reduces out to be 1/8. So 1/8. 1 minus an eighth, you get a common denominator. 8/8 minus 1/8 is 7/8. 7/8. Questions? Y'all okay? What's wrong? Just ask.
Can you repeat that? 1 minus 2 times 1/6?
These two I multiplied, right?
Yeah.
So I just did 2/1 times 1/16. That's 2/16, and then I reduced the fraction to become 1/8.
And then,
Common denominator, 8/8. Rewrite 1 is 8/8 minus 1/8, and that's 7/8. Right? You have to have the same denominator to put those together. Anything else? Okay. I didn't ask for this, but I'm just curious. I didn't ask. But what if I right now asked for tangent of 2 theta? Well, you could use the formula, couldn't you? Yes? But don't we already have sine of 2 theta? And cosine of 2 theta? So instead of using the formula, couldn't I just rewrite this as sine 2 theta over cosine 2 theta? I know that sine 2 theta is root 15/8, and I know that cosine theta is 7/8, and then I can keep dot flip. So that would just become root 15 over 7. I didn't ask for that. I just want to show you that if you know what sine 2 theta is and you know what cosine 2 theta is, the easiest way to get tangent 2 theta is just to take those and make a ratio out of them. As opposed to using the formula, you would still get the same answer, but that's going to be more work. It's quicker. Okay, good? Let's do part C. For part C, I need to know what sine of theta over 2 is. Okay. Please pay attention. This one has a little bit of a tricky part to it. Sine of theta over 2. By definition, it's plus or minus the square root of, according to the formula, 1 minus cosine theta over 2, right? That's the formula for sine of theta over 2. See the plus or minus? That means when I sit here and plug in cosine theta, when I plug that in and figure out what this is, I'm getting two answers. That's not acceptable. We can only have one answer.
Would it be positive because we're in the first quadrant?
Almost. Yes, I don't want to say because we're in the first quadrant. We are in the first quadrant, but theta's in the first quadrant, isn't it? Theta's in the first quadrant. We're not looking at theta anymore. We're looking at theta over 2, aren't we? So where's theta over 2? We'll look at that in a second. Let's first just plug stuff in. Do we know what cosine theta is? It is root 15, what was it? Root 15 over 8. Root 15 over 8, and then all of that is divided by 2, right? So far, it's plus or minus the square root of 1 minus that number, and that's it, right? All of that over 2? Pardon me?
Over 8
I thought it was
I don't remember. I erased it.
I think it's 4.
Oh, it was 4. Yeah, it was 4. It was 4.
Cosine of theta is 15 over 4.
It was 4?
Yes.
Yeah, that's right. Yeah. Thank you. Yeah, that is 4 down there. Okay, now that is the correct.
I have 15 over 8.
It
What?
was over 8. Yeah. I have that.
You're talking about cosine 2 theta,
Oh, yeah.
right?
Yeah.
Go back to the original drawing that I had over here, right? And cosine theta there. That's what we're plugging in here. Got it? Okay.
Oh.
All right, so this is the answer, right? I can start cleaning this up. And I'll tell you right now, on the test, because of time, on the test on Tuesday, you give me that answer, I'm happy. Okay, well, we're not done yet. We need to figure out if it's plus or minus. But you don't need to, on the test, simplify this. I just want you to move on because time. But just to do it, we'd need a common denominator, so we'd rewrite this as 4 over 4. So we could put those together, so it becomes 4 minus root 15. All of that over the common denominator 4, all divided by 2. But then you look at 2 as a fraction, 2 over 1, and then you keep dot flip. So this would become